Hello and welcome to Postgres FM, a weekly show about all things PostgreSQL. I am Michael, founder of PG Mustard, and today I am joined by Chelsea Dole, staff software engineer and tech lead of the data storage team at Brex, and speaker at several prestigious Postgres conferences over the past couple of years. Thank you so much for joining me, Chelsea.
Thanks so much for having me, Michael.
Wonderful. Well, I have seen several of your talks and loved how well you've explained a few concepts now. One of those was bloat. And looking back at our previous episodes, I realized we hadn't actually done an episode on bloat itself. We've done plenty that mention it, that are around it, but I loved your explanations and I'm looking forward to having a chat with you about what it is, how people can think about it, and some strategies around it.
Thank you. Well, as a Postgres FM loyal listener, I've definitely listened to a couple of those, bloat sphere conversations, let's say. So it's nice to be addressing it more directly.
Yeah, awesome. So in terms of where to start, I guess we should cover what is bloat. How do you think about it?
So Postgres bloat basically occurs as a function of MVCC and its kind of extension of vacuum. So in MVCC, all the actions you're doing, inserts, updates, deletes, those are all actually updates or editing metadata on a tuple, not hard deleting it in place. And this is basically allows MVCC to be both compliant with ACID and still fast, so it doesn't slow it down extremely slow. When those tuples are generally hard deleted is through vacuum, which, runs every now and again, depending on your configurations in auto vacuum. But if auto vacuum can't keep up and you have lots of those inserts and updates and deletes, then you can get into a state where your Postgres pages are basically bin packed with a bunch of dead or soft deleted tuples. And that leads to bloat. So bloat is the state where you have these table pages that are full of basically useless data that vacuum is hurrying to kind of run around and catch up. And so Postgres has to keep on adding new empty pages to the end of your heap, which leads to all sorts of, I'd say, non-optimal outcomes. So too long didn't read. It's unoptimal tuple density in your pages.
Yeah, I really like that. So if we end up in a situation where a large proportion of our table, maybe including the indexes, is sparsely stored on disk, that has knock-on effects, and that's referred to as a table with a lot of bloat. I've thought about it in the past as almost the diff between the table's current state and if we completely rebuilt that table with its indexes. Like the diff, I think of as bloat. I don't think it's the only definition that's acceptable because of like fill factor and things. Like there are other technical details, but I like it because I think it's quite practical and in terms of what it means. So, but why is this a problem? Like, when have you seen this cause issues, and how bad are these issues?
There's a huge spectrum there, and I would first preface by saying, I wouldn't call this a hot take, but maybe a lukewarm take, is that bloat is really not always a problem. I think that a lot of people think of it as this, oh God, our tables are bloated. What are we ever going to do? But there's plenty of situations where you can have a bloated table that's serviceable and you're able to get it to a slightly better state without any drastic measures. But the main issue that bloat can cause, which can lead to downstream issues, is really increased I/O. And I/O is sort of the grandfather of all these downstream issues that nobody likes, like high latency on your reads. It leads to I/O because essentially, if you think of it logically, like if I have 10 rows across 2 pages. If I do a sequential scan, I've now scanned 2 pages. That's a certain amount of I/O. But if I have really bad tuple density, if I've got table bloat, then maybe I'm scanning 10 rows or 10 tuples across 8 pages. And so I'm scanning the same amount of data, but I just had, 4x the I/O. So that can lead to downstream negative effects with reads, of course. And you guys have talked a couple times about explain buffers and things like that. So that's a really good way to sort of see off the cuff, whether you're using an appropriate amount of I/O. But as I said, there are places where you can have, some amount of table bloat and it's not really causing an issue. I would say that where I look for it as the biggest long-term issue to solve and really address is those workloads that are going to be very update and delete heavy. having some bloat on like a normal workload, if your users aren't seeing effects on latency through the IO, I would sometimes just say shrug, the important thing is the end-to-end experience and the long-term maintainability for you as a dev.
Yeah, love that, and very practical as well. I've seen a couple of your talks on this, and you mentioned IO, but you mentioned it quite late on, and I'm like, oh yeah, like it is as simple as that, really. Obviously, there are other bad things, like it's taken up more disk space, right? Like it's taken up more space in memory, but ultimately, user experience wise, that's normally what a lot of us are fighting with, especially on busy systems. So slow queries that users are reporting is a natural sign. How do you go from that to realizing, oh, my problem is a bloated table?
I think there's sort of two paths for that in my experience. The first one is before you ever know what bloat is, how do you discover bloat? And I would say that usually the path is you have a really bloated system and there's really no other explanation for it until you go down those paths and try to figure it out. For myself, just sort of going through how I discovered table bloat, thinking back, I've worked, I would say, in Postgres at scale, the last two companies I've worked at. Before that, with it more as like a passing just tool I happened to use. And I saw it in great scale when I first started at Brex. And the way that I actually saw it is that we had a developer reach out and they said, hey, I have this, let's say, 50 gigabytes of tables total on this server. There's only one database. And for some reason, we're like almost running out of disk. Why do I have where's all this space going? Because I can see my table size and then remaining table space on disk. We use RDS on cloud, so you're able to see all that pretty easily. And I went and I said, I actually don't totally know. Let me check this out. And when I went and checked it out, I could see that there was just a ton of bloat. And here, interestingly, the bloat was actually coming from a toast table bloat.
Oh, nice.
I know, which is like an interesting little side quest here conversationally. But, toast is just other tables, the oversized storage technique or whatever fun acronym they made up with it. Those are just tables under the hood too, so they can also get bloated. So I'd say that was my first time needing to go through the entire song and dance of bloat that needed to be fixed through, I would say, like strong measures versus maybe just, tinkering some little stats here and there. But I think that once you know what bloat is, it's pretty easy to look out for it. Operationally, there's observability tools and dashboards. You can instrument your own. I think a whole lot of DBAs have their own, private stash or ideally GitHub open source stash of like fun queries they like to use or extensions they have in their back pocket. And we can dive a little more into those if you want. But I think that there's sort of those two paths. There's the path of, oh God, what's going on? And then the path of once you've seen it, you can kind of pattern match.
Yeah, nice. I like the system level like path in, and I because of my background and the tool I work on, I see it more from the other direction. So somebody looking at an incredibly slow read query that has no right being that slow and using explain analyze buffers. And as you mentioned, it like when we say incredibly bloated, you could easily have at least before Postgres 14, which had some great especially good optimization in it. You could have an index that was 10 times bigger than it needs to be. If you, let's say you re-index concurrently, the result afterwards might be 10 times smaller. So that's a significant amount of extra reads you might be doing, especially if you're returning a bunch of rows. So you mentioned like 8 reads instead of 1, but if you're looking at the last 1,000 rows, if you're doing 8,000 instead of 1,000, you start to notice that in latency. So it's quite cool. We used to call the tip table bloat likelihood, and I renamed it a couple of years ago to read efficiency, partly because of your it goes back to your density question again. It's not necessarily bloat, but it's not necessarily about the likelihood of it. It's more about the efficiency of those reads, and it might be a locality issue, which is somewhat bloat related as well. So yeah, love this. Great. So you mentioned, and you've spoken before about queries to estimate and other techniques for looking into like getting more maybe accurate or depending on your definition of accurate measures of this. What's your advice on minimizing this, dealing with it?
Yeah, I guess the first thing to the measure of how to identify whether you have bloat or how much you have and decide what to do with it. The first step there is really, again, kind of a trade-off of what matters to you. Does the speed and low system impact matter to you in this sort of DBA process of figuring out how much bloat you have? Or does accuracy of the exact percentage of bloat or the exact tuple count and being 100% sure that your stats are right matter to you? And so again, kind of like I said in the discussion about how bloat can kind of be okay or not something you really need to deal with in certain situations, this is one where you kind of get to decide your priorities. If your priority is 100% accuracy, or I would say also, if you have downtime hours on your database where you can easily do this without any user effect, or if you have a small system and for whatever reason you happen to be, bloated through your own write patterns, but it's not actually that important, then I would suggest pgstat-tuple. pgstat-tuple is a Postgres contrib module, and basically it gives you some functions that you're able to run, and they will basically do a sequential scan through a target table, or I think through a target database if you want to run all tables, and it will return to you the count of live dead tuples, free space map stuff, as well as a few other statistics. And that one I would say is on the side of you have resources to spare. You're not going to impact users because CPU does spike during this, and there's no way to get around the sequential scan because you can't exactly index it. The point is to actually look at the pages. So it's always going to be a sequential scan. The other option is through using, I would say, estimation queries. And these tend to leverage internal tables already used by Postgres or kept up to date during the analyze process. So these would be like PG class rel tuples and things like that will estimate the number of live dead tuples you have based on a sampling during analyze. So before you run anything that's an estimate, you do want to run analyze, right before, but then you're able to guess a proportion based on a sampling of your table data. This is a better option, I would say, for really high criticality systems or extremely large tables. If you have a 500 gigabyte, 800 gigabyte table, or even just one that's 80 gigs, but is very, very critical for users, and maybe you're already kind of medium on CPU, you can't stand those resources, then there's really no downside to just using a table sample. There's no reason that this number needs to be precise.
Yeah. So what is alarming? Well, I guess the answer is it depends. But in fact, I've rewatched your talk recently, so I know I'm stealing from you there. But you've got some great rules of thumb on what you consider to be bad on the table bloat front.
Yeah, well, I don't think I could possibly steal it depends because that's just like everybody in engineering should be saying it depends all the time. But, my personal rules of thumb, speaking just for myself, is that on very small tables, bloat is not a problem. So a gigabyte, 2 gigabytes, that, as I'm saying, is very, very small. Even if you would see up to 75% bloat, out of vacuum will be able to take care of this. The total impact to your system, there's just no way that it can be high or significant, knock on wood. I'm sure somebody will comment with some counterexample, but at least in mine. Beyond that, I would say if you get to 1 to 30 gigabyte range, I would say 25% bloat. So 25% of your total table space being taken by dead tuples is acceptable. And then as you go higher from about 30 gigs, I would say you want to inch that acceptability downwards. So I would say once you get up to 100 gigabytes, I would aim for like 18%. And then I would flatline at about 18%. One important thing is you should never expect 0% dead tuples. If you completely rebuild a table, or if you fix every auto vacuum setting, or you've used an extension and repacked it, you still will have some bloat, and that's okay.
Yeah, right. Like unless you're going to show off because you've got like an append only table with no bloat. But if you've got updates and deletes, it's a trade off of the system, right? It's the trade off of the design that Postgres has given us. You've recommended this talk a few times. I'm most of the way through watching it, but Peter Gagan's given another great talk that is criminally underwatched at 200 views. So I'm going to share that. But it mentions some of the trade-offs that Postgres are making in this area. So it's guaranteed. I think as soon as we start doing updates and deletes, it's guaranteed that at least past a certain like frequency of those updates and deletes, they're going to have some bloat. So yeah, it's a really good point.
Yeah, there's no wholesale way to avoid it. It's more mitigating the downstream effects and making sure you don't accidentally look up and realize you're in a crazy situation in a couple months or years.
I'm curious though, I understand totally kind of as you get larger data volumes, trying to aim for a smaller percentage bloat, because like in real terms, that's more gigabytes of bloat or more pages that could be being scanned through for reads and things like that. But where did 18% come from? Like trying to get it lower than that, like fighting some update heavy tables, or where that seems quite a specific number to me for like a like rule of thumb.
Yeah, great question. And actually, this is the first time I've been asked this question, which I
No
appreciate.
way.
The first answer to why 18% or why these numbers is, as someone who watches Postgres talks and as somebody who takes it in, I have to admit there's part of me that gets annoyed when nobody gives real numbers.
Mm-hmm.
And I realize that it comes from the reality of it depends, as we already kind of espoused on, but I really wanted to provide something concrete. And so when I gave those numbers, I thought about my previous projects and I thought about, okay, well, what happens if I completely rebuild this table or I repack it and don't insert anything? Usually you would see table bloat around 8 to 10% then still, at least in my experience, because if you're rebuilding a table, at least if you're using extension like PG repack, for example, or PG squeeze, it's still going to need to kind of build up and write all the live data into it as it's rebuilding the duplicate table. So you're not going to end up at like 0% unless you, I believe, I'm assuming unless you, vacuum full. And so 18% came out of, I'd say, like opportunism of what I wanted to provide, and also just on experience of when I started to see a tipping point into performance. And when you start to get far enough that you can't really recover it without rewrites. So the reason I would say 18% is not because 20% or 25% even on a large table is the end of the world, but because I think once you start slipping into that more bloated table space at large tables, it's harder to recover from, and it needs more drastic measures than a little tuning here and there. And also, if you imagine you have a 1 terabyte table, which I know that I've had before at companies, then if you get to 20% of dead tuples, you now have 200 gigabytes of just bloat. So at scale, that becomes money, whether you're in the cloud or not, you're paying for that disk. That's kind of another downstream negative effect other than IO. So it's kind of, it's money, it's personal experience, and it's also just wanting to put a sticker and a number on something so you have a target to aim at.
Yeah, I really like that. I agree. It's difficult without any real numbers, but it also like you could have said 15%. I probably wouldn't have questioned it. It's more practical. It's more likely to be based on your real experience, which I liked a lot. Cool. So I wanted to come back to you mentioned TOAST and the acronym or probably backronym. If you've come across that phrase, yeah. That's a really fascinating case that I don't think I've not spoken to anybody about, but it makes like intuitive sense because of the nature of TOAST, we could have potentially large values across multiple pages, but I would have guessed they would be more easily reused. But I'm not. But that's a total guess. Did you have any more details on that?
Well, I'm sure I'll get some of this possibly wrong, but I think actually it's surprising that we don't see TOAST in more situations of bloat, because when you're updating a value in TOAST, to my knowledge, it's not able to be as intelligent as other update methods can be. So you're actually replacing or updating more often than not. So TOAST tables themselves, as I guess a background in case anybody listening is like not familiar, what happens is if you have an extended field, you have extended and non-extended data types in Postgres. If you have an extended field, so things such as JSON-B or, varchars with, I think, longer limits or byte A, then all these are examples when they can go over the maximum single tuple size. If they reach that threshold, then Postgres will compress it through some method, depending on your Postgres version, and they'll just store it in a separate table called TOAST table. And in the main table, let's say you have a users table, then that's basically just a pointer to this TOAST table. So in the example I mentioned before, when I ran into bloat on the TOAST table, the reason you would see this is maybe you have a small table even. It could be a 5 gigabyte table, but every row in this is extremely large data types. I'm sure we've all seen those tables where there's 5 columns and each of them is like a massive JSON B value. And they could be updating those all the time. You could be doing field updates. You could be doing anything. And if you get up to a certain TPS on that, then every single time you do an update, it's going to be rewriting that value in the toast table. And Postgres does look at toast, as far as I know, like just any other table. So AutoVacuum is running it on it the same exact way. I have a talk on partitioning, and I kind of say the same. Partitioning to me is like UX. It's DBA UX. We see it as one table. Postgres just sees tables. And same thing with toast. And so in that case, we had a small table that was just super high update for those very large fields. And, correct me if I'm wrong, Michael, maybe you know more about this, but I think that the nature of how Toast does those updates is they're not able to do, I think, key value updates in Toast fields. They have to always rewrite. Does that sound right to you?
Yeah, well, it sounds like any other value in Postgres, right? Like it's a single entity. So like even in a large text field, without it being toasted, if you it pasted in the entirety of War and Peace and then only changed one word, but it was all a single value, I believe we'd need a new tuple bad example because that one definitely wouldn't fit in a single page, so it would be toasted.
Yes.
But yeah, let's say you took a 1 kilobyte chunk of text and changed only like a few characters in it, I think it would work the exact same way. So yeah.
The only caveat to that, I believe, is that when you toast something, you toast an object, you toast it in chunks of a discrete size. So if you did toast War and Peace, then, it would be, you would run into the tuple length issue in Toast as well. Toast doesn't have a longer, maximum tuple length. It's just that it will chunk it via some algorithm, compress it, and then so War and Peace will actually be a pointer to, let's say, 10 tuples, all of them compressed. So I believe that when you edit one word, you fix your spelling mistake. Leo Tolstoy really has to go back and fix that. Then when he retoasts it, then he has to recompress and rechunk all those 10 values again, not just the one. So I think it might be, we're figuring this out, really talking about it. I think it might be something that scales the issue with increased size of the object itself.
Yeah, I'd love to hear from anybody who has dealt with this or looked into it or written it. Sometimes we get some quite in-depth responses, which we love. The question, I guess, is let's say we've got something that's spanning tens of kilobytes, so multiple pages. Your 8-page example might be good. And we rewrite it, so we get 8 more pages. The question then is what happens to the 8 previous ones once they get marked as dead, and if they could get reused easily, we shouldn't get too much bloat. But if they're getting, I guess, if AutoVacuum can't keep up, that's when it accelerates. So it would make sense in a system, for example, where AutoVacuum isn't able to keep up with that toast table for some reason, or maybe it's been disabled on that table, or anyway.
Totally. That can also be a place where you need to tune AutoVacuum max workers higher, because AutoVacuum max workers defaults to 3. And this doesn't really have an impact depending on your table size. It has an impact depending on your table count. So if you have, I would say, more than hundreds, so getting into thousands of tables, and many of them are large, so maybe the AutoVacuum worker takes a long time on one table, that's where you're going to want to start tuning that up, giving extra resources on your server over to Vacuum compared to servicing queries, I would say, for the greater good.
Yeah, and just to be clear, when you say like hundreds of tables, we're counting each partition as a table in that case?
Yeah, each partition.
Yeah, makes a lot of sense. Cool. So anything I haven't asked you about that I should have done, or any other tips for this?
Let's see. I think the only thing we didn't get around to that I think I would want to make sure I shill is some more details about how to fix a bloated table once you see it. So if you have discovered you have a loaded table, let's say that you're above that metric, that rule of thumb maybe well above it. Like I said, when I found that toast table, it was like 95% bloat. So that explained a lot. And I would say that at that point, there's a couple routes you need to go down. The first is to recognize that bloat is caused by a combination of auto vacuum configuration and update and delete heavy workloads. Just one of them won't get you there. It's both together. And so if you're only a little bit bloated, maybe you just kind of keyed onto it via some, observability metric or, warning level ping you got in some place or other. At that point, I would recommend going the route of tuning your auto vacuum configurations, as well as really talking to the dev team or working as a dev yourself to figure out whether there's anything you can do to reduce the volume or difficulty of those updates and deletes. Some common anti-patterns I see are things like cron jobs that run every day or week and delete like a huge amount of data. And they often think they're being helpful when in reality they can be kind of degrading the quality and, IO return value of that database. In terms of tuning configurations, usually you want to go one of two broad ways. You either give the server more resources for auto vacuum through auto vacuum max workers, or you tune it to run more frequently. So you tune auto vacuum to actually run more aggressively, which I generally recommend based on system defaults. Auto vacuum did get more aggressive in more recent versions of Postgres. However, it's still generally good to turn up like auto vacuum scale factor, especially if you have those large tables. It defaults to only triggering auto vacuum when 20% of your table is dead rows. So, that's already beyond, I would say, my recommended 18% goal. So if you really wanted to trigger more proactively, you would need to tune that down from 0.2 to, let's say, like 0.1 or far less. I see a lot of recommendations online that I've used as a user that suggest, every 1% or 3% of dead tuples.
Yeah, because for a huge table, that's still a lot of tuples. We could still be talking about tens of thousands, hundreds of thousands, even millions of tuples.
And by the time that it's actually done, you could be up higher than that because that's when it triggers. And what if it takes hours and hours?
Yeah, absolutely.
If you do get really, really far behind, you check the clock and you're up to that like 90% bloat table, that is a good time to consider rebuilding the table. If you can afford it, vacuum full, Most people can't these days if it's a user-facing application, so that's the reality. But I always say that first because there are situations in which you can, again, looking from the user perspective, and it's a lot easier. The other thing you could do is use an extension like PG Repack or PG Squeeze to rewrite it. And this is basically creates a shadow table duplicate schema. It will copy over all the data, use triggers to update all the data coming in from one to another. And then once it's all caught up, it will, within an access exclusive lock which lasts, less than a second, definitely, it will basically switch the table names so the prod traffic points towards the new table. This is something that I have seen be flaky. I wouldn't personally recommend automating PG Repack. I've seen and heard of cases in various talks and just through friends in the industry, people that try to automate PG Repack. And, I've seen it lead to a lot of incidents and issues. I've personally never run into an issue where there's any data loss because in the case that you just kill the PID of PG Repack, for example, you just have some dead tables you have to manually drop. The duplicate ones aren't complete, so you use the old one. But I've heard of it causing other issues. So I would say careful, but I wouldn't stray away from it totally.
Nice. I've always thought of it as like reindex concurrently, but for the whole table. Is that a reasonable comparison, or I guess it's missing some subtlety around potential flakiness, but that can fail as well, right? Like if reindex concurrently fails, you can end up with some invalid indexes.
I think that's a really good analogy, actually, mainly because they're both non-transactional. Because, concurrently or anything concurrent, the thing that it's an unusual move by Postgres, and I'm sure there was a lot of discussion on the core team about this when they first started releasing concurrent features, because it's a decision by the core team to value the user Postgres experience by DBAs and applications over the strict rules of MVCC. Because when you create an index concurrently, if it fails, you have the invalid index. So it's not atomic. It's not able to roll back. And the same thing with PG repack. If it fails, then you have these invalid tables, invalid indexes that you need to drop. If you try to rerun it, it's not a no-op. You'll have to clean it up first.
Yep, cool. Okay, well, I'm glad that's good. So that's a really good point in terms of auto vacuum and in terms of repacking or vacuum full if you can afford the heavy locks, or if your system just doesn't have any users at a certain time of day or something like that, right? But it's rare, but it is common enough that I have been caught out by not recommending it a couple of times, which is super interesting. Cluster is in the same category, right? Like same as vacuum full, but you get to order it by an index, which can be helpful for like reads.
Definitely.
Cool. Last, in fact, you mentioned right at the beginning, and I had to bite my tongue not to jump straight on the pun because that's how my brain works. You mentioned having a hot take. So you talked quite a lot in the past about access patterns, and one point I loved was the idea of considering if you've got an update or delete heavy workload, which could be the reason you're in the situation. Do you even need to be doing those updates and deletes? Like that's a question that doesn't get asked very often, and you made a really good point. So there's that angle that I'd love you to talk on if you want to, and there's also the hot update optimization we have in Postgres that can be a huge help for some, like avoiding if you're aware of it, not indexing a certain column if you don't have to. Like there's some trade-offs there that might be interesting. I don't know if you've got experience with those.
Yeah, I guess so. So first address the first part of it. Glad you brought it up because this is definitely a strong opinion of mine, and I think that's something that comes from coming to being what I would describe as somewhere between the liminal space of a software engineer and a DBA through, back-end engineer to data engineer to DBA, just, sinking my way down into infrastructure. And, I think that I still tend to think from a perspective of a back-end or data engineer a lot of the time. And from that, I think that it's good for us to all remember that so many of these access patterns and writes, the biggest hammer you can use is to just not do it or to rewrite it. And if you're a DBA managing a couple or hundreds of databases, speaking for myself, I'm managing the hardware and the high level metrics. So I don't really have access or knowledge without talking to somebody into the why. Why do we have this query? Why do we have this database itself? What the heck's in it? And so I think that if you really want to address bloat, often the best thing you can do is to start a conversation and say, hey, what's the value of this? Can we simplify it? Do we need to be deleting this? Do we need to have this table? It's crazy how many times that I've dealt with a problem that way, and I've never needed to delve into the more, I would say, extensive measures. And also, if you can, keeping those relationships with people at your organization or whoever you're working on a project with to try to be able to let them keep that up by themselves. At my company, we've built some automation around, I'd say, like auto education as far as we can. We're still working on it, but a way to kind of allow developers to be proactively educated about how they're building their systems. And so I think that as much that you can do that and just, I would say, change the patterns from the code side is the quickest way. That's a PR.
Awesome. I was not expecting it to go that way. What's this automatic education thing? Is there anything you can share there?
Yeah. I will mea culpa here and say that I wish I could say it were a more, amazing system than it probably is. But we've used, for example, Git hooks and GitHub webhooks to automatically comment documentation that we've written on PRs. For example, if we see running a migration, we pin the migration guide to your PR rather than requesting us as reviewers, because I work in an organization of larger than, 1,000 people. So I don't want to be a blocker on your migration. I want to educate you. Same thing with partitioning. I wrote, after we dealt with partitioning stuff, you may have noticed that a lot of the talks I write are based off whatever the heck I'm struggling with at work. And so I wrote a very in-depth migration, partitioning migration guide, both for future people on my team, as well as people who might want to partition and need to understand why, how, whether it's a good idea. So I think that creating documentation is good, but we all know it falls out so quickly. You change one thing, it's deprecated, you forget about it, the person leaves. So I think that the underappreciated side of it is figuring out easy systems where you're auto commenting it or you're, pushing it towards people in a way that actually keeps it actively read.
Awesome. Sounds great. Is there anything else you'd like to plug or give a shout out to?
Not particularly. I think that I'm sort of a relative newbie to the Postgres community, being involved in the open source side. I've went to my first Postgres conference last year and then sort of ran at it at 100 miles an hour ever since then, which has been really fun to get involved. So I guess I would just say thank you to all you guys for inviting me in. It's been a great past year to being more involved in Postgres.
It's awesome to have you in the community. I still feel new and I feel like I've been here for like 5 or 6 years. So it's awesome having you here. You're a wonderful contributor to the community. Your talks are great. Please keep giving talks on issues you're hitting with Postgres. They're some of the most fascinating that the community can have, and also not common enough at conferences, I think, personally. So yeah, appreciate it, and appreciate the real numbers as well. So thank you so much, Chelsea.
Yeah, thank you for hosting this. I listen to you guys as many people do in the car. So same thing.
Oh, nice.
You guys keep me going with good things to read while yelling at various drivers on the road.
Well, apologies, you're probably gonna have to skip a week.
Oh, okay, yeah. Listening to your voice is too hard.
Tell me about it. Take care, Chelsea.
Thank you.